Now you can see how we can apply these rules of inferences on sentences in a knowledge base of a logical agent to prove all kinds of sentences. So imagine that an AI agent begins with the knowledge that if an animal has feathers, it implies that the animal is a bird. Now it comes across Harry, who does have feathers. By modus ponens, therefore, the AI agent can conclude that Harry is a bird. This completes the proof for our original goal of proving that Harry is a bird. Now let us suppose that the goal is to prove that Buzz does not have feathers. Once again, imagine an AI agent which begins with the knowledge that if an animal has feathers, it implies that the animal is a bird. The AI agent comes across an animal which is not a bird. Then by modus tollens, it can infer that Buzz must not have feathers. This completes the proof for our original goal of proving that Buzz does not have feathers. Okay, so now we have looked at two ways of proving the truth value of various sentences. The first way was just through truth tables. I could have sentences in logic, then I could write another sentence and ask myself, well, what is the truth value of this sentence? I could construct a truth table for that sentence composed of the truth values of all the predicates, some of which might be coming from earlier sentences. The second way in which we have seen how we can prove the truth value of sentences in logic is by applying these rules of inferences like modus ponens and modus tollens. This is very powerful, and in fact the power of this logic has been known since before the birth of AI. As computer scientists, however, we'll analyze this power in a slightly different way. Yes, we can use the method of truth tables to construct the truth table for any arbitrary sentence. However, if the sentence was complicated, then the truth table very soon will become very complex. Computationally, that is infeasible for very long, large sentences. Similarly, yes, we can apply simply modus ponens and modus tollens to find the truth value of many sentences. But if the knowledge base consisted of a very large number of sentences instead of just one or two sentences, then the kinds of inferences, the number of inferences I can draw from those sentences simply by applying modus ponens and modus tollens will be very large. Or if I had to find the truth value of a single sentence, then the different pathways I could take in order to get to the truth value of those sentences can make for a long, large problem space. So while these methods of proving the truth value of sentences in logic have been around for a long time, these methods are not computationally feasible, at least not for complex tasks, at least not for agents that have only limited computational resources and from whom we want near real-time performance.